Hello students, let us continue with the chemical properties of group 16 elements. Second property is reactivity with the halogen. So group 16 elements react with halogen to form different halides of the type EX2, EX4 and EX6. So E is the element of group 16 and X will be halogen. So EX2 means it form dihalides, EX4 means it forms tetrahalides. EX6 it means it forms hexahalides. So group 16 elements form different halides of the type dihalides, tetrahalides and hexahalides. While considering the stability of these halides, it will be in the decreasing order of fluorides, chlorides, bromides and iodides. So the stability of halides decreases in this order. So fluorides will have more stability and iodides are less stable. So stability of halides decreases in this order, that is fluorides, chlorides, bromides and iodides. Now consider the first element, oxygen. Oxygen forms dihalides with fluorine. So it forms fluoride, and that means difluoride. So oxygen forms dihalide with fluorine only. It will not form OCl2, OBr2, etc. So OCl2, OBr2, they are not possible. The only possibility of dihalide with oxygen, that is OF2. So we have already seen the reasons, that is oxygen and fluorine. If you are considering oxygen and fluorine, fluorine is more electronegative. So that is why it forms difluorides. It will not form dichlorides or dibromides, since chlorine and bromine are less electronegative than oxygen, but fluorine is more electronegative than oxygen, so it can form OF2. So that is the first point. But the other elements will form dichlorides or dibromides. Example, SCl2, SBr2 or SCCl2, SCBr2, etc. So sulfur, selenium, etc. that will form chlorides or bromides of the type EX2. That means dichloride or dibromide will be formed by other elements. But oxygen will not form chlorides or bromides, only fluoride will be there. So this will be formed, that means dichlorides or dibromides are formed, and this the hybridization of this type, the hybridization is sp3 hybridization in this case, and the geometry will be tetrahedral. So the shape of this type of molecule will be tetrahedral. So SCl2, that means the chlorides of sulfur, bromides of sulfur, or chlorides of selenium, bromides of selenium. So these dihalides are having hybridization sp3 and geometry will be tetrahedral. Now consider another possibility, that is it forms tetrahalides. Tetrahalides of the type EX4. So tetrahalides means SF4 is possible, SCF4 is possible, and TEF4 is possible, so etc. So in this case, SF4 is a gas, SCF4 is a liquid, TEF4 is a solid. So in this case, these are examples of tetrahalides. In this case, they are having sp3d hybridization. So sp3d hybridization, and this is having a geometry of trigonal, bipyramidal, or we can say it's a seesaw structure. So sp3d hybridization is there. In this case, SF4, SCF4, TEF4, etc. That means tetrafluorides of the type EX4. So in this case, it is having sp3d hybridization and the geometry will be seesaw shaped or trigonal bipyramidal. And SF4, this is gas, this is liquid and this is solid. Then consider hexafluorides of the type EX6. So here the example or the most stable hexafluoride, so most stable one. So the out of all fluorides or out of all fluorides, hexafluorides will be more stable. So out of all fluorides, that means if you are considering SF4 and SF6, these are two fluorides, but out of these two, SF6 will be more stable. So this is having a hybridization of the type hybridization sp3d2 hybridization. So sp3d2 hybridization and the geometry will be octahedral. So since it is having sp3d2 hybridization, the geometry will be octahedral. So hexafluorides are stable than tetrafluorides. So why SF6 is more stable? So SF6 is more stable. It's a question. So it is more stable than SF4. So SF6 is more stable than SF4. Or another question is SF6 is kinetically inert. Why? So these two questions can be answered like this. So SF6 is more stable. We have already seen SF6 is having an octahedral shape. So the structure will be like this. So since it is octahedral in nature, so this will be the structure of SF6. So SF6 is octahedral and this sulfur, so this sulfur is sterically hindered. So this sulfur is sterically hindered. So it is crowded with this all fluorine atoms and this SF6 is sterically hindered or sterically protected. It is sterically protected. So it is more stable. So it is more stable and it is sterically protected and it is kinetically inert. So it is kinetically inert. So in the case of SF4, we have seen it is having a seesaw structure. So here there will be the lone pairs of electrons and this will be the structure of SF4 and this is SF4 and this is a seesaw geometry and this is having sp3d hybridization. Here it is octahedral and sp3d2 hybridization. So these points are important. SF6 is octahedral and sp3d2 hybridization. This is sterically protected. This sulfur is sterically protected and it is crowded with all the fluorine atoms and this is kinetically inert. So this is an inert molecule or this is a stable molecule. But in this case, this is having a seesaw structure or sp3d hybridization. The lone pairs of electrons are here in the equatorial position and you know this is the equatorial bonds. These three positions are equatorial position and these are the axial positions and this position is having a lone pair of electrons and the other electrons or other atoms are like this and this is a seesaw structure and this is not at all stable or this is not sterically protected. Actually there is empty space. So there will be empty space and this is not stable. This is not stable. So if you are hydrolyzing, if we are hydrolyzing, so this SF6 will not hydrolyze easily. This SF6 will not hydrolyze easily, but SF4 will hydrolyze easily. So SF6 will not hydrolyze easily, but SF4 will hydrolyze easily because it is not sterically protected, or it is not stable. This is having empty space, so hydrolysis will take place easily. But in the case of SF6, it is sterically protected and this is kinetically inert and this is a stable molecule. So this is exceptionally stable. So SF6 is having octahedral geometry and SF4 have SF4 has seesaw geometry. So this geometry and hybridization, shape, etc. will be important, and that is an important point. So consider these SF6 and SF4. SF6 is more stable. So that is why hexafluorides are more stable. So here we need to consider SF6 and SF4. So SF6 is stable than SF4. So this is about the reactivity with halogen.